In 2024, it took the United States roughly 6 years to deliver a single destroyer. In that same period, China launched 11 major surface combatants. The question is no longer who builds the better ship. The question is who can survive the math. America's answer is not simply to reform its military specifications, but to build an entirely new class of warship that does not need them at all. The United States Navy fields the most survivable warships on Earth, yet it cannot produce them quickly enough to match the pace of competitors. Over the past 2 decades, the shipbuilding budget has nearly doubled, while the fleet has barely grown. The culprit is not a lack of money or technology, but a dense web of military specifications known as MIL SPEC that governs every weld, every cable, and every component. These standards guarantee extraordinary protection, but they also make construction excruciatingly slow. The Navy now faces a strategic choice: reform the system or find a way to build ships that are never subjected to it in the first place. MIL spec standards like MIL S901D for shock hardening and MIL STD 461 for electromagnetic compatibility were written to ensure warships could survive torpedo hits and near-miss nuclear blasts. Over decades, they expanded to cover almost every part of a vessel, from pipe welds to cybersecurity architecture. The certification process demands that each material, each procedure, and each worker be individually qualified and documented. When a single change to a welding robot requires months of approval from NAVSEA, the speed advantage of automation vanishes. What began as a rational defense against existential threats has calcified into a bureaucratic cage that prevents the Navy from adopting the rapid manufacturing techniques common in commercial shipyards. In South Korea, Hyundai Heavy Industries is targeting 80% automation of deck welding by 2030. And it has already cut welding time by 2/3, saving roughly $9 million per hull annually. The same class of robots exist in American yards, but they are restricted to simple, flat sections because MIL spec qualification for complex joints or high-strength steel like HY80 takes months. While a Korean yard can iterate a welding procedure in weeks under commercial classification rules, an American yard must submit the new procedure to the on-site SUPSH office, which then coordinates with NAVSEA, adding a review layer entirely absent in commercial shipbuilding. Consequently, even though the technology exists, American robots are forced to walk while Korean robots sprint. The bottleneck is not engineering, but the paperwork required to prove that a robotic weld can survive a war. Even if MIL spec restrictions were lifted overnight, American shipyards would still struggle because of a severe shortage of skilled outfitting workers. Installing hundreds of kilometers of cable remains stubbornly manual. Connecting combat systems and fitting modules inside a warship is still done by human hands, often in cramped compartments. No robot can crawl through narrow cableways or adapt on the fly to the distortions that occur when massive steel blocks are joined. The American Welding Society projects a shortage of over 300,000 welders by the end of this decade, and the scarcity of pipefitters and electricians is just as acute. This means that even if robots weld the hull twice as fast, the vessel still waits months for the human hands needed to pull cable and integrate electronics. The industrial base simply lacks the bodies to outfit ships at the tempo required. Faced with the mathematical impossibility of matching China's fleet hull for hull, the Navy has embraced a radical bypass: build warships that do not need MIL SPEC at all. Unmanned surface and underwater vessels carry no crew, so they do not require the shock hardening, fire suppression, or life support systems that trigger thousands of military specifications. By designing these platforms to commercial standards from the start, the Navy can use the same fast, automated panel lines that produce merchant ships. The May 2026 Shipbuilding Plan formally embeds this logic, targeting 83 unmanned vessels alongside traditional manned warships, according to the Navy's FY26 30-year plan briefed to Congress. It is a quiet admission that the legacy acquisition system cannot deliver enough destroyers and frigates quickly enough to deter a Pacific conflict. The Modular Attack Surface Craft program, which replaced the earlier LUSV effort, demonstrates exactly how this bypass works in practice. The Navy's request explicitly calls for a non-exquisite vessel design that maximizes commercial standards, enabling construction and repair at multiple shipyards. The target is to deliver a prototype within 18 months of contract award, a timeline impossible under normal MIL SPEC processes. MASC builds on 5 years of DARPA and ONR prototypes, including Ghost Fleet Overlord and Sea Hunter, lending credibility to that aggressive schedule. These craft carry containerized payloads on standard ISO footprints, meaning the combat system is sealed inside a ruggedized box, while the vessel itself is simply a fast, cheap platform. The hull is commercial, the payload is military. Ghost Fleet Overlord USVs have already fired SM-6 missiles from containerized Mark 70 launchers in Navy experiments, proving that a non-MIL SPEC ship can perform lethal missions. Pulling off this bypass requires not just a new design philosophy, but a different legal procurement pathway. The Pentagon uses Other Transaction Authority, or OTA, to acquire prototypes like MASC without following the federal acquisition regulation that normally mandates MIL SPEC conformance. OTA agreements function more like commercial contracts, allowing the Navy to move at the speed of industry rather than the speed of compliance documentation. This legal mechanism is the invisible engine behind the unmanned fleet because it shields the program from the 1,000-page requirements that would otherwise creep in. Without OTA, any experimental USV would eventually be suffocated by the same specifications that slow manned shipbuilding. In effect, the Navy is building an entirely separate acquisition pipeline for a parallel fleet. The greatest threat to this strategy is not Chinese shipyards, but the institutional gravity of the Pentagon itself. History shows that once an unmanned vessel proves useful, there is immense pressure to add just a little more survivability, just a little more hardening, just one more MIL SPEC clause. The Zumwalt-class destroyer was originally planned as a fleet of 32 advanced stealth warships, yet only 3 were built before the program collapsed under its own cost and complexity. What began as a revolutionary design became a symbol of how ambitious requirements can inflate a platform beyond affordability. Congress has already signaled discomfort with weaponized USVs that lack full shock certification, and every congressional hearing is an opportunity to load new demands onto the program. If each new unmanned platform incrementally absorbs the very standards it was designed to avoid, the cost and timeline will climb until the bypass collapses. The Navy will then be left with a handful of exquisite robotic ships that are just as slow to build as manned destroyers, and the numbers gap with China will widen further. Here is the uncomfortable truth beneath all the technical data and budget numbers. America is not going to overtake China by reforming MIL SPEC for manned warships anytime soon. That fight alone could burn through a generation of careers and still end in stalemate. The real way forward is quieter and, in some ways, humbler. A shadow fleet built under commercial rules, welded by robots already proven in Asian yards, assembled by workers from Gulf Coast oil service towns who never imagined they would be arming the Navy. The welding war will not be decided by the strongest weld, the most survivable joint, or the thickest specification binder. It will be decided by the weld that is finished first and repeated 1,000 times without anyone waiting for a stamp. If the Navy manages to keep its unmanned program clean, truly clean, free from the slow creep of red tape, then America can put enough hulls to see that the math starts to make sense again. If it cannot, the iron cage will close one more time, and we will keep building the world's finest ships while steadily, quietly, losing the race to have enough of them.